Hey everybody, so today we're going to be talking about number 13 off of the 2024 AMC 8 paper. And we're not going to talk about how scuffed my setup is, and instead we're going to dive right into the problem. So the problem says, Buzz Bunny is hopping up and down a set of stairs, one step at a time, which honestly, what a legend. Get that exercise, king. And how many ways can Buzz Bunny start on the ground, so starting on the ground, make a sequence of six hops, and then end up right back on the ground, right back to where you started. So the example that they give us is, again, starting from the ground. We're going to say that this is the ground, going up, up, down, down, up, down. So a couple of key observations that I noticed here are, one, that we're starting and ending back on, oh my goodness, starting and ending up back at the same spot. And the reason that this is relevant is in order for us to start at 0 and end back up on 0 with, just +1 ups and -1 downs. So let's say our ups are +1 and then our downs are -1. You have to have an equal number of +1s and -1s, right? And since there's 6 hops, that means that we have to have 3 ups and 3 downs in the entire sequence. So even in the example, when you notice it's up, up, so 2 ups there, down, down, 2 downs there, an up and then a down, there's 3 ups and 3 downs. The second interesting thing about this problem is, since we're starting on the ground, you can't ever go below the ground, which means you have to start with a +1. And the number of +1s that Buzz Bunny hops always has to be greater than or equal to the number of -1s. So the number of ups must be at least as many as the number of downs at any given point in the sequence, because you can't end up below the ground, which, Buzz Bunny is alive and healthy here. So we're going to use kind of like a visualization technique for counting all the different combinations, just because I feel like, one, it's a little bit nicer for my visual learners because, letters are hard. And the second thing is that, letters take a lot of time to write, which, if a lot of you might be thinking that, oh, I'll just do like U, U, D, D, U, D, and like write out all the 6 different possibilities, that would definitely work, very valid, but it does take a little bit of effort to write all those out. And in the AMC 8, or like in a timed paper when you have a time constraint, the amount of time that something takes does matter. So I just wanted to introduce a little visualization tactic that is actually borrowed from a math concept that we're not going to delve too much into, but it's super cool. So I highly recommend that you check it out. It's called a dyck path. And a dyck path is literally this. So it's essentially, a dyck path is any path that starts at 0, consists of a sequence of +1s and -1s, so up and down, right? Such that the number of ups is always greater than or equal to the number of downs. And what that translates to visually is that you never go below this 0 ground line. So you start at the ground, end up at the ground, have a sequence of +1s and -1s, but you never go below this line. So in fact, let's try to write out the example that they gave us, which is up, up, right? So this is +1, right? All of these are just going to be our ups, and all of these are going to be our downs. So down, up. So +1, up, up, and then down, down, and then up, down, right? So that's one possibility. Now, you could also, another possibility could be that you do it in reverse order, where you do the up, down, and then up, up, down, down. But when we start going down that path, it can get a little confusing to think about what we have and haven't accounted for, same as if we were using just the letters to write this out. So let's try to think about this in a systematic way. We know that we have to start with a +1 initially, an up initially, because you can't go down when you're already on the ground. So let's maybe try to write down or make all of the paths that start with just 1 up initially. So if we're going just 1 up, right, that means that we're probably coming back down at that point. So at this point, we can do that sequence of 1 up, 1 down, and have Buzz Bunny loiter around the same step, which honestly, kind of a vibe. Get this nice zigzag pattern. So this is one possibility, right? +1, -1, +1, -1, +1, -1. Or we can have Buzz Bunny experience new heights by going up 2 steps and come down those 2 steps. See? So again, this is all a 6-step path. So there's 2 possibilities where you start with +1 because, there's not really any other options for 2 ups and 2 downs besides the 2 that we've written out. So now let's try the set of sequences where you have 2 ups in the beginning. So for that, oh my goodness, I'm running out of space. Sorry about this. But we start with 1 up and then 2 ups, right? And because it's only 2 ups, the next step has to be a down, right? But at that point, you can go right back up and then come down because you've had your 3 up steps. Or you can go up, up, down, down, and up, down, a path that you've seen already several times. And that seems to be the only option if you're going up 2 steps because there's only, 1 up at that point that's left for you to do. So now let's move on to the set of 3 ups. So you do 1, 2, 3, and we know that there only are 3 ups in the sequence because the sequence only has 6 hops, which means that you have to come down after that point, and that's the only possibility. So that's the plus 3 case. So in total, we have 2 options for the +1 case, 2 options for the +2 case, and 1 option for the +3 case, for a total of 5 options for Buzz Bunny. Yeah, I hope this made sense. If this didn't, please feel free to reach out to me in the comments, and I'll do my best to respond as soon as I see it. And best of luck and happy mathing.